Hi, I'm Ray, G4NSJ, back with another episode about the Master Clock. GPO Master Clock, number 36, Mark 6, made by Gents of Leicester, England. Right, that's the intro over. What I've been doing is building a power supply for a start for the 4 volt, the Pendulum drive magnet, 24 volts for the slave clock when I get it. I've used, probably can't see that, clock's just there, computer cable, 8 core stuff from the clock to the power supply box. I'm going to start off the video showing you the various contacts. There's the 1 second contacts, 6 seconds, which I don't use, I'm not using 1 or 6, 30 second contact, which the pulse goes out every 30 seconds. That is for the slave clock, half-minute pulses. The drive magnet contacts and all that set up. Have a look at the video clip. I'll just take you around the various contacts. This is the hip toggle. Let me get something to point with. You see that little toggle thing there? Every now and then it locks into that. You'll see in a second. Not now. There it goes and makes contact. Now we've got 1, 2, 3, 4, 5, then it's contact. So 5 swings between contacts. Now that is very difficult to set up, I must say, very difficult. It's got to be just right. Some people say you need between 6 and 12. Other people have said they get 25 swings between contacts. I can't quite see how that would happen. 25 swings is a lot. To be honest, I don't think it matters too much. Let's move up to the magnet, the drive magnet. This is what they call the Pendulum drive magnet. It's 2 solenoids in series, about 10 ohms I believe. They're 5 ohms each, I think. This pulls the pendulum across whenever the contacts are made on the hip toggle down below. I've added a diode there across the solenoid. That is to suppress back EMF because the solenoid was going clunk every time the contacts opened. Now this is the this is the 6 second wheel. You see the deeper, if I can show you, you see that deeper there, that deeper one, every 6 seconds, that allows this to be pushed over. You'll see in a minute. Here we go, there's one. There's one where the contacts close. That's every 6 seconds. There's a deeper notch in that wheel. There's another one. There's another one. That has to be set up properly. There's an adjustment screw there. There's one behind. There are various adjustments that you can make on that to set it up properly. If this pendulum has to push too far over here to make these contacts, it slows the pendulum down, which is not what we want. We want it as free swinging as possible to get as many swings without energizing the solenoid as possible. The other side, this is the 30 second contact here. Okay, there's the contacts. There's the deeper notch there. Can you see that? Slightly deeper. And as that comes up to the top, it pushes the contacts. Here we go. Not yet. This one coming up now. And you probably heard the relay go over in my power supply box, which is on the top of the clock unit. I'll show you that in a second. Now again, this doesn't want to slow the pendulum down too much. You don't want to put too much pressure on the pendulum. So you want these contacts here. There's the 30 second one there. That just allows this to swing in a little bit further and move this. Right, this one now. There it goes. That's every 30 seconds. Now up here, these are in parallel because we want 1 second. If it was just one pair here, then you'll see, look, contact, 1, 2, 1, 2, 2 seconds it would be. So it's a 1 second, 1 second there, they're in parallel. And again, these arms here can move like that, they can swing. You don't want too much pressure. You just want these contacts either side to be made, just about made, to send the 1 second pulse to the clock or whatever. I mean, in my case, I don't need the 1 second pulse. It's a 30-second, half-minute pulse that the slave clock will work on, when I get a slave clock, that is. And again, all this here, all this setup, there's a little screw there. You can then turn this little axle thing in the middle, which adjusts how far this is pushed over. It's quite a setup. And here you adjust that little, undo that, then you can turn this. There's a little weight in there, same the other side. It's quite a palaver setting it up. And the thing is, if you move the clock to a different location, all this has to be set up again. What I shall do eventually is mount it on the wall and then set it all up, and it'll be done. I think I mentioned in the last video the floor in here is uneven. I've got bits of carpet everywhere, so the clock wants to be dead upright. If I move it at all, even if I just lean it back slightly or to one side, the pendulum's all out, everything's out. So it's got to be fixed properly to the wall downstairs eventually. Then set up all the contacts properly. As I said, I don't need the 1 second contact or the 6 second one. What some people do, what I've read online, is they stop that operating, the 1 second one, stop that operating so as to put no pressure on the pendulum at all. The 6 second one, kind of decouple that so that doesn't operate. Just have the pulse for the magnet and the 30-second one. That clonking every now and then that you could hear, the little toggle goes into the thing like that and pushes up. Sometimes it lands on the edge. Now I've read about this again, I keep reading stuff about all this. Sometimes it goes on the edge and clonk. That it seems to be a common problem. I've read other people that have got that problem. So I don't know what to do about that. Probably nothing, it works all right. Now onto the power supply. The wiring's a mess. The thing is, with just briefly, when I'm talking about making those contacts, they've only got to make quickly, all right, the 30-second one I'm talking about, that's the only one that counts. Make it quickly, so it's not, if you've got the pendulum pushing like that to make a long contact, if you see what I mean, pressure on the pendulum, and it's not necessary, you just want it to quickly go like that to energize the relay. If you want a sort of longer, let's call it a time constant on the relay, stick an electrolytic capacitor across the coil. So that'll hold the relay on for a little bit longer. Depends how long you want the pulse. Was it 500 milliseconds they said for the 24 volt pulse? I don't know. We'll see about that when I get a clock. I'll just adjust things so the clock works. Have a look at the power supply. Sorry about the mess. There's wires everywhere. I was going to cable tie them or lace them. And I thought, I know what will happen if I do that. I'll then want to change something and have to cut it all off and start again. So anyway, here's the power supply. This is the power supply. Bit of a mess of wiring here, as you can see. This is the 12 volt supply from the mains. There's a 12 volt chock block. Under here are two relays. 12 volt relay, 24 volt relay. This buck converter here, down converter, takes 12 volts down to about 4.5 for the drive magnet, pendulum drive magnet. This buck converter here is an up converter, takes 12 volts to 24. The reason I've got two relays, the 24 volts by the way, is for the slave clock, 24 volt solenoid in there, which wants a 24 volt pulse every 30 seconds. Well, it will do when I get a clock. I haven't got one at the moment. To save the contacts in the master clock from having to carry excessive current, I've used a small relay there, which every 30 seconds energizes briefly. That in turn energises the larger relay here, the 24 volt relay, which sends the 24 volt pulse, these here, out of there when I get the clock. These LED series resistors, I need to put sleeving over those. I'm also going to increase the value of these because the LEDs on the front are far too bright. I'll show you that later. They're far too bright. It just looks a bit ridiculous. I don't have to have flashing LEDs on the front, but I'll talk about that later anyway. So there it is, 12 volt power supply, 4.5 volts, 24 volts. Connection block there, Cat 5 is it, or Cat 6 computer cable, because it's 8 core. That goes to the clock, so it's a nice simple cable, and the 2 relays under there. There's the power supply box on top. The red light that's on all the time, that's to show the power's connected. To the right of that is the 1 second one, every second. And the one on this end near me is 6 seconds. There it goes. And the far left is 30 seconds when it decides to come on. There it goes, and the relay clicked. So that's standing on top of the clock. There it all is. Almost ready to go into the dining room, out of my radio room because it's in my way here. Just a couple of things. That pendulum drive magnet, as they call it, the solenoids there, it's 2 5-ohm coils in series, so 10 ohms. It says, various manuals and things I've read, it says you want to watch the current. 4 volts isn't quite enough for my pendulum swinging. It's not quite enough. I've taken it up to 5 volts. Now before you say, oh no, you'll burn it out and all that, watch the current. They reckon 450 milliamps to 500 milliamps, okay, is all right. Don't go over half an amp. 500 milliamps top. I've got about 480 milliamps, and I probably will be able to. This is the beauty of the buck converters. I can wind the voltage up or down a little bit, or a lot actually. So I read somewhere, some chap the other day, he had his on 8 volts or something. Someone else was running on 12 volts. Well, that pendulum's going to swing through the side of the clock case. But that's important though. Watch the current. Doesn't matter too much what the voltage is. And as I said earlier, the idea of the relays is to save the clock contacts in there. I don't want those burning out. They've got series resistor and capacitor across all the contacts for spark quenching purposes, which will help prolong the life of the contacts. But bear in mind, this, I don't know how old this is. 60s, is it? I think I read somewhere this could be the 60s. So yes, the LEDs on the front, I don't know why I put those on there really. I just thought, as I've got the computer cable, 8 core, I just thought I might as well have a 1 second LED flashing and a 6 second and all that. I don't know. I will certainly dim them so they're very dim. They're, at night in here, they light up the room. It looks like a disco. Anyway, right, I just checked my notes. I think that's it. Yeah, that's about it. The thing about the slave clocks, I've been looking on eBay and other places. The thing is with these slave clocks, a lot of them, they're quite expensive. Some are £200 or £300. I found 1 or 2 nice ones between 80 and 100, but not working, parts only. They've put that because they can't test them. They don't know how to test them. So I don't want to spend like 100 quid and find that the solenoid's burnt out. Someone's put it across the 230 volt mains, you know, thinking it's an ordinary clock. So it's a bit difficult trying to know what to do about that. I'm not in a hurry for the slave clock. Also online, I've seen just the unit, the solenoid, the gearing, the shaft out the front for the hands to go on there's the clock face. Again, the little unit, there's one at 25 quid, one at 35 or something. Parts only, not working. Again, they've put that because they can't test it. One said taken from removed from a working clock or something, I don't know. So I'm not too sure what to do. I don't mind spending a bit on a clock if it's working. I don't want to get it here, it turns up in the post and ends up scrap. And I certainly don't want to have to rewind a solenoid. Okay, I think that is it now. I shall leave you in peace. Hope you found that interesting. I'm learning all the time. As I said in the last video, I know nothing about these clocks. I've never had one. I mean, I know how they work, but I've never actually owned one or mucked about with one. So I've got some wood stain. I'm going to do the outside. I've got the cabinet here, the clock. That's why I keep looking here. I'm looking at the clock. I'm going to put a bit of wood stain on the cabinet because there are quite a few scratches here and there. Give it a good polish. Clean the glass door. There's the glass door. You can just see that. Look. Clean the glass door on the front there and the back. Ready to put in the dining room. My wife's idea. She said, I found a place in the dining room. You can put it on the wall there. Right, good news. Got to have the XYL on the side, haven't you? Thanks for watching, and there will be a third part of video, of course, part 3, when I get the clock. Thanks for watching. Take care. Bye-bye for now.